Hello, students. Let us uh, continue discussing the time series modeling. In last lecture, we discussed the existence of unit root, and finally, we observed that if unit root is present, then there exists the problem of autocorrelation and non-stationarity is available. If series is non-stationary, I told you that what we will be having spurious econometric modeling. Like I show you. Suppose we are no. So let us first of all talk about what we are going to discuss today. We are going to discuss the concept of co-integration. Okay. So what co-integration is basically, you can say that if if we are modeling yt is equal to alpha plus beta xt plus ut, okay, and it is noticed that it is noticed that yt is integrated of order say 0 and xt is non-stationary and integrated of order 1. I'm saying yt is stationary, that's why I have written I0. I0 means integrated of order 0. Okay, and xt is I1 series. Then et, that is the sample estimate of ut, then et series will be will be a non-stationary et will be a non-stationary series, that is et will be integrated of probably order 1. Okay, in such case we may conclude autocorrelation autocorrelation is serious, and hence estimates of model 1, let it be the model 1, estimates of model 1 will be spurious. Okay, thus we want yt and xt to be co-integrated, that is stationary of same order such that the residual item is stationary at levels, that is et is integrated of order 0. In simple, if yt is integrated of order, if yt is integrated of order m, xt is integrated of order n, and m not if m is equal to n, then yt and xt are said to be co-integrated with each other. That is an instantaneous relationship oblique long run relationship exists. Long run relationship exists between two series, right? So we conclude that there exists a long run relationship between xt and yt. They are of same wavelength. They have some instantaneous impact, like as x rises, yt either rises or falls. That is, beta cap is statistically significant, and other term is stationary, right? Uh, Let me tell you, the co-integration is a desired property. Okay, it's not a problem like stationarity is desired. The co-integration is a desired property of an econometric model or of a time series based econometric model, and hence different models have been different models बोल लीजिए different methods बोल लीजिए different methods have been given to detect or model the co-integration relationship. These models are: number one, Engle-Granger co-integration method. Number two, Johansson approach. Johansson approach. And third one is ARDL, autoregressive distributed lag models. Obviously, there are different variants of each model, like Johnson approach. We have five different models in Johnson approach, and then even within whatever ARDL modeling, we have further variants like NARDL, nonlinear autoregressive models. But in your syllabi, we have basics of ARDL and Johnson approaches, not the very advanced versions are there. Obviously, if you will be using these approaches in your research, you people can go for those advancements. No, I will be starting with the Engle-Granger co-integration process. Let me tell you, Engle-Granger co-integration is applicable. Test is applicable only in bivariate models, wherein one variable is dependent and other one is independent. Like I have written model number one, where yt is dependent and xt is independent. So in bivariate models, only Engle-Granger co-integration process is applicable. Johnson is applicable in the multivariate time series models, where Oval series are, they have same order of integration. They are non-stationary, but they have same order of integration. Then you can go ahead with the Johnson approach. Generally, we say if all series are I1 or integrated of order 1, then we generally go for Johnson approach. The third is autoregressive distributed lag model. So ARDL can be applied even on bivariate models and even on multivariate models. Many times we say that ARDL is more powerful than Johnson approach. So these days people are extensively using ARDL and NARDL models, nonlinear autoregressive models. So in empirical research, these models are, they are being widely used these days. So Engle, Granger, and Johnson approaches are depreciated approaches, and the recent one is the ARDL approach. Now, ARDL is applicable when we have the combination of I node and I1 series, like we have, some variables are integrated of order zero, that is, they are stationary at levels, and some are integrated of order 1, they are stationary at order 1, means when we take first difference of that variable, then those they become stationary. So but ARDL is applicable when we have a mixture of the I node and I1 variable, because when we have mixture of I node I1 variables, even then it is possible that you will be having a stationary error term, that is ET is integrated of order 0. That's why ARDL is applicable in such cases. Johnson, there is strict, there is a strict condition for Johnson, that Johnson is applicable when all series are integrated of same order. They are non-stationary and they are integrated of same order. Then only Johnson is applicable. But if you have some series integrated of order 0 and some are integrated of order 1, then we apply autoregressive distributed lag models. So let us start with the Engle-Granger co-integration process. What is Engle-Granger method? So Engle-Granger test of co-integration. Okay. I told you it is applicable only in bivariate models where one variable is dependent and another one is independent. Suppose we need to estimate, we need to estimate yt is equal to alpha plus beta xt plus ut. This model we have to estimate. The steps are number one, estimate parameters of one using ordinary least square method. Okay, and obtain the sample estimates of ut, that is et. Okay, how to obtain? Et will be is equal to actual yt minus yt cap, that is yt minus yt cap is alpha cap minus beta cap xt. So this will give you the, means first of all you have to apply obviously OLS on this model. OLS, after OLS estimation you have to store the residual. Okay, so step 2, apply ADF test of unit root and see whether ET is origin stationary or not. Okay, if ET is origin stationary, that is Et is integrated of order 0, then then we conclude yt and xt are integrated of then we conclude yt and xt are co-integrated, and yt is equal to alpha cap plus beta cap xt is the long run oblique co-integration relationship. ठीक है बच्चे? तो yt is equal to alpha cap plus beta cap xt plus et. This can be written. Okay. Can I write it as alpha cap, if I have to write this in matrix form, into 1 xt plus लिख सकता हूँ कि नहीं बच्चे?
Yes, sir.
Yes, sir, we can write.
This is called co-integration vector. This is called co-integration vector. This is my co-integration vector. No, even this cannot be written as exactly the co-integration vector. If even the right co-integration vector can be written as sorry. You have to remove this. We have skipped one step. Sorry. Yeah. What we have written as this. So yt is equal to alpha cap plus beta cap xt plus et. Can I write et is equal to yt minus alpha cap minus beta cap xt लिख सकता हूँ? So this can be written as
Yes, sir.
1 minus alpha cap minus beta cap yt 1 xt लिख सकता हूँ in matrix notation.
Right, sir.
But now this is called co-integration vector. ठीक है बच्चे? This is called co-integration vector. Okay. The vector 1 minus alpha minus beta will be called as co-integration vector if et is level stationary, that is integrated of order 0. Okay. This vector states long run relationship between xt and yt, and beta is long run impact of xt on yt, right? To get short run relationship, see if co-integration exists, long run relationship exists, to get the short run relationship, error correction equation is estimated. Okay. Error correction equation is estimated. Now, what is error correction estimate? Error correction equation. The error correction equation is. But what is error correction equation basically? Uh, we will regress first difference is obviously if we assume that yt is stationary of order 1, then first difference of yt will be regressed upon say curly node plus curly 1 delta xt. Okay, these are two parameters. You can use any symbol. I am using curly node and curly 1. Okay, this is like alpha intercept. That was intercept of level series. This is the intercept of first difference series. So this is the slope impact of change in xt on change in yt minus plus psi et minus 1 plus vt, where psi is convergence parameter, okay, associated with error correction term et. So et minus 1 is error correction term and psi is the convergence parameter. Okay. For a stable model, for a stable co-integration or long run relationship, the psi must be negative and statistically significant. Okay. This shows convergence. Okay. This shows convergence to long run, convergence to long run equilibrium relationship, equilibrium relationship or co-integration relationship if the relationship breaks because of some shock, right? If because of some shock this relationship breaks, and then a negative psi will represent that this relationship will be re-achieved, and obviously many times we say that uh, this psi can also be used to get the time period it will take, the economy will take to converge back to equilibrium value. Okay, Now this curly node and curly one, if I write it like this, curly node is the short term intercept. This curly one is the short run impact. Okay, so short run impact of xt on yt. This is ECM. This is error correction term. Sorry. Okay, this is the error term. Error term of error correction model. See, some basics I want to clarify. That's why I'm elaborating this model. If I put et minus 1, let it be number 2. Okay, let it be number 2. Or let it be, no, let et be number 2 and that model be number 3. Yeah, this model be number 3. If I substitute 2 and 3, can I write it as, if I substitute 2 and 3, can I get it as substituting 2 and 3, can I write delta yt is equal to curly node plus curly 1 delta xt plus psi into, at the place of et minus 1, can I write it as 1 minus alpha cap minus beta cap into yt1 xt प्लस वीटी कर सकता हूँ ना, क्यों बच्चों? That's why this psi is called convergence parameter to this cointegration vector. Okay, why it must be negative? Because ultimately this psi becomes the unit root coefficient. आप इसको multiply करके देख लो. Can I elaborate this? If I elaborate, then it becomes delta yt is equal to curly 0 plus curly 1 delta xt plus psi. Sorry, here I will be having yt minus 1, no? Because it is et minus 1, xt minus 1. Yes. So can I write it as psi yt minus 1, okay, minus this alpha cap, okay, minus psi beta cap xt minus 1 plus bt लिख सकता हूँ, okay. And if we regress, if you remember ADF equation or DF equation, delta y is regressed upon yt minus 1, right? So this becomes what? Unit root coefficient. This becomes unit root coefficient, and hence phi must be less than 0. Okay, then only your model will be stable. So that was the theory of what you say, Engle Granger test of co-integration, and obviously the error correction term. Now let us estimate this model with Gretl. Let's open the Gretl file, open data. I'm opening the same time series file. Data is monthly 1991, month 4 onwards. Okay, apply. Now go to model, multivariate time series. See, we have direct co-integration angle Granger test. To apply co-integration test angle Granger, since I am telling you people that it is applicable only on bivariate model where one is dependent, other one is independent. Let us suppose I want to see whether LM3 is dependent upon IIP or not. Okay. Test down from maximum order selection. Let us select Bayesian information criteria. Show details of regression. If you want to include, you may include seasonal dummies. Okay, seasonal dummies, I told you if it's a monthly data, 11 dummies will be introduced. They will be included. Choice is yours. Let us first of all exclude those dummies. We have different models. Test without constant, that is origin stationarity. Test with constant and trend, with constant and quadratic trend. This is basically about the co-integration relationship. Is it present or means around origin? Is it present around drift? Is it present around the quadratic trend or not? Let us first of all talk about without constant or with constant only. If I am using only intercept, click OK. Testing for a unit root in LM3 ADF test is given. Okay. See, this is negative but statistically insignificant. So LM3 has a unit root. Okay. LM3 has a unit root. This is ADF test of IIP, and we may see that IIP is having a unit root. Okay. It is negative but statistically insignificant. Both series are having unit root, means they are integrated of same order. Now co-integration test. This is the co-integration regression panel. Constant is present. LIIP is independent variable. We can see that IIP means output is positively and significantly affecting. Why significantly? Because p-value is less than 0.05. So this coefficient is statistically significant. Now whether this coefficient is what do you say is representing the long run relationship or not, whether these regression estimates are representing long run relationship or not, the test is available here. See, augmented decay test for U hat, like we are obtaining E series. This is U hat series that has been obtained. So U hat series, you can see that ADF test is available. We can say that this is the tau statistics minus 1.2812 for U hat series, and p value is 0.83. So null cannot be rejected because 0.05, so it's much above 0.05. It's 0.8367. So null cannot be rejected, and null is the existence of unit root. So there exists a unit root in U hat series. If you see, there is evidence for see, notes are there is evidence for co-integration relationship if the unit root hypothesis is not rejected for individual variable. For individual variable, unit root hypothesis uh, cannot be rejected. Okay, means there exists unit root. The unit root hypothesis is rejected for residual, but here it is not rejected for residual. Once the unit root hypothesis is not rejected for this U hat series, the error term series, it means there exists the problem of non-stationarity of error, and hence co-integration is not present between these two series. So we can't take this relationship as a co-integration relationship. Hope you got my point. Tomorrow I will show you how we can estimate the error correction model with the, see, error correction estimation is feasible if co-integration exists. Since co-integration doesn't exist in our model, there is no viability in estimating this error correction term. Here, long run relationship is absent. We can talk about only what you say, the short run relationship, if it exists or not. We can simply create the differences of yt and xt and can regress the difference of yt on difference of xt. That will give us a short run relationship. That's all about Engle-Granger test of co-integration. We'll be meeting with the Joe Johnson co-integration test tomorrow in the next lecture. Thank you so much. Now I will be taking your attendance.